Okay, now let's examine what happens when the denominator doesn't completely factor. So into linear factors. So in this example, if we look at the denominator, we can factor out an x, but x squared plus 4 can't be factored any further, right? If it was x squared minus 4, we could factor it into x plus 2 times x minus 2. But x squared plus 4 doesn't factor. The way you can tell whether a quadratic factors or not, if you have a quadratic of the form ax squared plus bx plus c, if you remember the quadratic formula, the thing under the square root called the discriminant, b squared minus 4ac, if that's positive, so that in the quadratic formula you'd get an answer, then it does factor. So it won't factor if this is less than 0. So in my in x squared plus 4, a would be 1, b would be 0, and c would be 4. And if you do b squared minus 4ac, you'd get minus 16, which is less than 0, and therefore it doesn't factor. Okay, so what do I do? How do I set up the partial fraction decomposition in that case? Well, the x is fine. The x leads to a partial fraction of the form a over x. And the x squared plus 4, we're going to have in the numerator, instead of just having a number, we're going to have a linear factor. So bx plus c is what we want to put in the numerator. Okay. So it's very important that you set up the correct form of the decomposition. Okay. So once you've done that, then actually finding a, b, and c is always pretty much the same procedure. So we are going to multiply both left and right of this equation by x times x squared plus 4. On the left, we're just going to have 2x squared minus x plus 4, since the whole denominator factors. And then when we distribute the x times x squared plus 4, for the first term, the x cancels, and we get a times x squared plus 4. And for the second term, the x squared plus 4 cancels, so we just get bx plus c times x. Okay. And then we could put in values of x to simplify and find a, b, and c. But let me show you another method that's often useful in finding a, b, and c. So I'm going to write this as ax squared plus 4a plus bx squared plus cx, just distributing everything. And then I'm going to group my x squared terms together. So I've got an ax squared and a bx squared, so that's an a plus b times x squared. And then I've only got one x term there, cx, and I've got one constant for a. And then I can set whatever's in front of x squared on one side of the equation equal to whatever's in front of x squared on the other side of the equation. So I can write 2 is equal to a plus b. And similarly, if I look at the x terms, I've got a minus 1 in front of x there, and I've got a c in front of x there, so that means minus 1 equals c. So c is minus 1. And then, let's see, so let's use this color. We've got a constant of 4, and that should equal a constant over there, which is 4a. So 4 equals 4a, which means a is 1. And then we go back to the first equation. If a is 1 and a plus b is 2, then b must be 1 as well. And so we get that 2x squared minus x plus 4 over x times x squared plus 4 is equal to 1 over x plus bx, let's be b is 1, so x minus 1 over x squared plus 4. So if I want to integrate, I would integrate that, but I can split this up into the integral of 1 over x plus the integral of x over x squared plus 4, and then minus the integral of 1 over x squared plus 4. And the first one is the natural log of x. The next one would be, you do a u substitution with u equal x squared plus 4, and since du is 2x dx, you're going to get a 1/2 log of x squared plus 4. And then the third one is our arctangent formula, so that would be 1/2 arctan of x over 2 plus c. And there's our answer. Number 7, example 7 here is similar, but now we've got to be careful. Always check the degrees before you set up your decomposition, because you might have to do long division, and in this case we do. The degrees are the same. So if I take 4x squared minus 3x plus 2 and divide by 4x squared minus 4x plus 3, I'm going to get 1, 4x squared minus 4x plus 3, and when I subtract, I'm going to get x minus 1. So so this is, and that's it, right? So this is going to be 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. Now, what am I going to do with that fraction? Can I factor 4x squared minus 4x plus 3? Well, if I look at b squared minus 4ac, b is minus 4, so that's 16, a is 4, and c is 3. I can see that that's negative, so that doesn't factor. So in order to integrate x minus 1 over 4x squared minus 4x plus 3 dx, well, you would think that you would do a partial fraction decomposition, but it's already in the decomposed as much as we can, because the numerator is already of the form ax plus b. Okay? So so what I have to do here, right, if the denominator were x squared plus 4, I would just split it up into two fractions, and the first one would be a natural log, and the second one would be our arctangent, like the example we just did. But because we've got an x term, we have to complete the square. Okay? So, so 4x squared minus 4x plus 3 is 4 times x squared minus x plus 3. Right? We factor out whatever's in front of x squared, and we factor it out of both the x squared and the x term. We take half of 1 and square it and add it to complete the square, but because that's inside the parentheses, we've really added 1, and so we've got to subtract 1, so we don't change the original expression. So this is 4 times x minus 1/2 squared plus 2, which is 4u squared plus 2, where u is x minus 1/2. And then du would be dx. So if you rewrite this with u's, you're going to get x is u plus 1/2 minus 1 over 4u squared plus 2 du. And that's u minus 1/2 over 4u squared plus 2 du. And that one you can split up into the integral of u over 4u squared plus 2 du minus 1/2 the integral of 1 over 4u squared plus 2 du. Okay, so let's leave this one alone for a second. And I'm going to just factor out a 4 from that denominator, make this an eighth. And that's going to be 1 over u squared plus a half. So the first one you can do with a u substitution, I guess a y substitution, y equals 4u squared plus 2. Du then would be 8u du, so you're going to have to divide by 8 and get 1/8 the log of 4u squared plus 2. Okay, so this one, you just do u, or y, is 4u squared plus 2, and can compute that. And then the other one is an integral of u squared, 1 over u squared plus a squared. So I know that that is, right, so this is u squared plus a squared with a equal to the square root, 1 over the square root of 2. And so I get 1 over a, so that's square root of 2, times the arctan of u over a, so square root of 2u. So let's see if we can write my answer here. Remember, I had done the long division, so I had the integral of 1. So I'm going to get x plus 1/8 natural log of 4u squared plus 2, but that's in terms of x, that's 4x squared minus 4x plus 3, minus square root of 2 over 8 arctan of square root of 2u, and u was x minus a half, so square root of 2 times x minus a half plus c. So there's our answer right there. Okay, so here we're just going to write down what the form of the partial fraction decomposition without actually working out the integral, just so you know how the decomposition works depending on what the denominator looks like. So I've factored out the denominator. I've got a linear factor here with x, another linear factor x minus 1, and then x squared plus x plus 1 is not going to factor, and x squared plus 1 doesn't factor. So our decomposition would look like an a over x plus a b over x minus 1 plus, and then since these are irreducible quadratics, the x squared plus x plus 1, I would have to have a cx plus d in the numerator. And then x squared plus 1 cubed, that works the same way as with the linear factors if I have them repeated. So if it was just x squared plus 1, I'd have an ex plus f over x squared plus 1. But because it's cubed, I'm actually going to have a gx plus h over x squared plus 1 squared, and an ix plus j over an x squared plus 1 cubed. Okay, and if I'd had x cubed plus x squared plus 1 over x squared times x minus 1 cubed times x squared plus 1 to the 4th, then that would be an a over x plus a b over x squared, because I have x squared twice, so I get 2 terms for that. And they're linear, so the numerator is just a number. Same thing with x minus 1. I have x minus 1 cubed, so I'm going to get 3 terms. C over x minus 1, d over x minus 1 squared, and e over x minus 1 cubed. And since I have an x squared plus 1 to the fourth, and that's a quadratic, the